Okay, we are on the section 1.6, page 9 on your notes. And we are going to talk about polynomial and rational functions. This portion, we are still doing the review and from your 154 class. So let's talk about what are polynomials. We talk about polynomials. What are polynomials? What do you think? What are polynomials? What does poly mean? Poly means many terms, right? So for polynomials, and they have many terms, right? So many terms put it together, added together. And each term, how does each term look like? Each term has what? X to some powers, right? X to the n power with the coefficient in front of it. Then you have many terms added together. Then your n is what? From 0, 1, all the way. No negative. Negative, if power is negative, we mean different thing. Then we have a different name for it. Okay, let's see some example. So if I write it this way, in 2x squared minus, so do I have a polynomials? Yes. How many terms they are? 3 terms, right? It's separated by add and subtract sign. If I write it this way, 2x squared minus x plus 5 equals 0, do we call this a polynomial? No. Why not? Because it is equation, not a polynomial. Polynomial has polynomials have different styles. One term we call it what? Monomial. 2 terms, binomial. 3 terms, trinomial. 4th term and 5th term, right? So if I write it this way, x negative 1, is this a polynomial? No. If we write 1 over x squared, is this polynomial? No. What does x negative 1 mean? Negative 1 doesn't mean negative 1. We talked about it before. Negative is a symbol. It means a reciprocal. So that means 1 over x. And 1 over x squared we can write as what? X negative 2. So this is not a polynomial. Then let's talk about something called rational. Rational means ratio. We mentioned those. We have what? Something called rational numbers, right? Then what does rational number mean? It means a number. And the reasonable number is, it means what? A fraction style, ratio. So it's like A over B, fraction. So formally we use this term, a quotient means a division, right? Of 2 numbers and A over B, of course. Denominator cannot be 0. We are going to talk about rational functions. So we start from rational numbers, okay? Then let's talk about something we call rational expressions. Expressions are math language to express an idea, okay? or ideas. So it's a what? Ratio. Expressions, then on math, expressions we use polynomials sometimes to express things. So it's a rational, so it's a quotient of what? Two polynomials. Okay, two polynomials, right? So polynomial, we write the function style like f of x, p of x over q of x. So same thing, the denominator cannot be 0. Then we also talk about something called rational equations. What kind of things we call equations? And you have an equal sign, right? It's a fraction style of the polynomials, rational expression with equal sign. So example, it looks like, right, 1 over, is this a rational expression? So if you have rational expression equals something, it becomes a rational equation. So rational, we are going to talk about rational function, and we are going to use this in this class, and everything is in terms of functions. So your profit, your revenue are in terms of the time, right? So things like, so we use function style equals what? Rational expression. So if it's like expression with the style, of course, what do we have? The denominator cannot be 0. Okay? So that's doing more formally. And we are going to talk about polynomial and rational functions. That's how we will define them. So let's write down the definition. Okay, so a polynomial function is what? A function, right? And in the form of what? Polynomial style, right? So it's a function in terms of what? Polynomial style. So that's a polynomial style. It's each term looks like that. So with finite terms. So we start from, you start to learn more abstract notation symbols. So that's nth term. Next one will be one less all the way, right? Till what? A2, x2, ax1 plus what? A0. It's a constant. So you have nth term, actually 1 to n, then plus constant. So n plus 1 terms for this function, okay? For, we call it polynomial. A rational function is what? A function, okay, with what kind of form? Rational function with the rational expression. So we write it this way. It's a function, then rational expression will be those style, so it's a fraction, right? And what happened to our p of x and q of x? P of x and q of x, those are what? Polynomials. Then, of course, the denominator cannot be 0. So formally we defined this term. Then we are going to use those function style to do the revenue, profit, and cost type things. Now we are going to talk about something called vertical asymptotes and horizontal asymptotes. Okay, what does that mean? Then how we are going to use it? It's like vertical asymptote if you have a graph, right? So if you have things like this, then asymptote means what? If your graph continue, then you will approach something but never touch this line. So that line becomes a vertical asymptote. Horizontal asymptote means what? If you have graph like this, okay? So if you have a graph like this, you will go somewhere, continue, but you will be limited, bounded by a vertical line, okay? We are not going to test you on those things, but you need to have this concept if you continue to study in economics or calculus more advanced. You might need those concepts, okay? We are still on page 9. So how we are going to describe a vertical asymptote means this is the vertical line, say, okay, x equals 0, right? And the graph tends toward positive or negative infinity as the input approach to. So this line is x equals 0, right? Then f of x, the line y approach to the infinity. So it may look like this way. Okay, two lines may be that way, or if I have something like this, if this is my x equals 3, okay, if simple one, if I have things go approach, x approach to 3, then your y value keep going down. Or it might like this, y value keep going up but never touch the line. So formally we describe it this way. Okay, so when the graph, the point on the graph is all the x and y's, right? Y is the value go up and down for the graph. For this one, that means when x approach to this point, x approach to 0, what happened to the y? Y is our f of x. The line, the value of the line, it will approach to a negative infinity, right? Never touch it, this line. So bounded by this line. So that's called vertical asymptote. For this one, it's like x approach to 3, right? From this side, positive 3, then our f of x approach to what? Negative infinity. Or on this graph, x approach to what? From the left-hand side, approach to 3, f of x approach to what? Positive infinity. So we have situation like that, okay? So it's bounded by the x equals 3, the vertical line. So we call that one x equals 3 is vertical asymptote. That one, x equals 0, becomes x become x equals 0 is the vertical asymptote. So for horizontal asymptote, how does it look like? Like this one, if this is phi, how do you write this line, boundary line? You write y equals phi, right? So same thing if, okay? So that means when x approach to what? When x go to the infinity, but your y, right? Y is bounded by, that's your f of x. It's this line. It's bounded by what? The value, whatever that is, it's phi, right? So then we say the horizontal line y equals phi would be its what? Horizontal asymptote. So let's see some examples. And for rational functions, we talk about rational functions, right? So this one is like, you know, if your business is a certain way, then your revenue, say, will be limited to a boundary condition sometimes. So a rational function, if for a rational function, right, you write what? P of x over Q of x. So has what? It has a condition, has a vertical asymptote. X equals C. If Q of C equals 0, right? But of course, the top one is not 0. That means that when denominator is 0, it's like 1 over x. If you use calculator or computer to graph, how does it look like? From last class, you can see our graph. We do have 1 over x graph. It's on your page 5. You can take a look. 1 over x for this example. So the graph, x is 1, it's 1, 2 become half, quarter. So it looks like this, right? Negative, it looks like this. It's on your page 5. And let's see, 1 over x is on the bottom in the middle. So what happened to this one? You can see for the denominator, when the denominator is 0, that means when x is c and, right? When x is 0, then Q of 0 doesn't actually exist, okay? So you have this situation, and it's bounded by, when we have what? When x approach to 0, what's your y? Your y, when you approach to, from the right hand side, okay? So approach to 0, what's the y? Y approach to infinity. So this is a very abstract concept, okay? So like this one, x approach to 0, you approach to infinity. So you have what? Horizontal, then x approach to left hand side, then you have what? Y approach to negative infinity. So this line is your vertical asymptote. So this concept is very abstract. We are not going to use a whole lot in this class, but I just introduce the concept. I will not test you on this, okay? So a function this one q of 0 is not 0. It doesn't really apply this that much. We just say use this as an example to see the vertical asymptote, okay? So maybe we use another example. So this one, when do they have a horizontal asymptote? Let's see. When we have this one, horizontal asymptote for this one look like this, right? Horizontal asymptote. So let's take a look. Horizontal asymptote is what? Y equal to 0. Actually, horizontal asymptote is y equal to 0, all right? If you are going to learn this symbol, limit, okay, x to infinity, this one is C. Or limit x to the negative infinity. This is a calculus, mainly is calculus symbol, but we don't emphasize on in this class, okay? So it's confusing, isn't it? Okay, so when it is talking about when x approach to infinity, right? Then your C for this case is what? C is 0. So that's your y equals 0. So infinity, then your y value, f of x means y value approach to 0. Okay, y approach to 0, right? So C is 0 when x approach to infinity. When x approach to negative infinity, then you'll see this value is 0, then y, the line approach to 0. Okay, so just give you an idea, there are more things about asymptote. At least you have a little bit idea what do asymptotes mean. It's the boundary, then your f of x and y value will not go beyond and that line, and it is bounded by the line. That's what it means. Let's take a look on your page 9 on the bottom. There, we are going to talk about graphs for those functions. So for polynomial functions, we are going to talk about in section 2.8 later, okay? Now we just look at the rational functions first, okay? So see some example. If my f of x equals 3x plus 2 and x minus 2. What kind of functions we have? Rational expressions with function, we call it rational function. So you will use the calculator or computer to graph. Then you will see when you graph it, okay, we need to practice the computer to look over how to graph so we can see actually how do they look like, then we use it as such later on, okay? So when you graph it, then you will see this one. This is your x equals 2, then you have this one, somewhere, okay, -3. So that would be your y equals 3, not -3. Okay, let's see what happened. Okay, so the graph, the line actually look like this. And this one will look like this. That means for this function, we have what? Y equals 3 will be your horizontal, right? Asymptote. Then this x equals 2 will be your what? Vertical asymptote. In pre-calculus class, and they will go through it in more detail, show you how to find those asymptotes, okay, and mathematically and with calculator, okay. But for us, we just graph it. We understand how do those asymptotes look like. It's your boundary lines. Then let's see. Let's take a look another one. So if I have f of x equals 2x plus 3, x minus 1, when we graph it, so it will look like this. And you will have, because its denominator cannot be 0, so when x is 1, something will happen, right? When you approach to from right hand side, the number is super small. When you divide it, the curve become what? Very huge. The number will become huge. Okay, so then this is y equals 2. So the graph look like that. And this 1, 2, 3, somewhere there. So the graph look like that. So here, what do we have? Then y equals 2 is your horizontal asymptote, and x equals 1 is your vertical asymptote. So we are learning the concepts of asymptotes. Then by using calculators, so we know how the graph will behave, you know, and how the functions will behave. If you look this one, f of x equals x squared minus 4, what do we have? Rational function. Okay, so the graph use computer or calculator, then you will find out it will look like this. You need to type in and try it out and actually see it. Okay, so that would be, this one is x equals 2. Here is x equals -2 and y equals 3. So the graph, you actually want to spend some time to use the calculator if you have one, or at the beginning we show you on the website you can use this site, right? So www.decimals.com. Just type in this one. When you type in into the, you do y equals, right? When you type in this, you do y equals what? 3x squared divided by, you better put the parentheses around the denominator. So you divide the whole thing. Then when you graph it, you can see the graph will look like this way. Okay, that's right here. So when you type in this way, 3x squared over the whole thing. Okay, so your graph will look like here, here, and here. So you have horizontal asymptote because the denominator cannot be 0, so that will be your limitation for the x. So you have x equals what? When you x squared, x minus 4 equals 0, then you have x minus 2, x plus 2 equals 0. Then you have what? X equals 2 or x equals negative 2. These two lines, the x cannot be those points at these 2 points. So it becomes what? Your vertical asymptotes, your limitation. Then you also have a horizontal asymptote by looking at the graphs. Let's look the next thing, absolute value functions. So absolute value function, for example, we can have this, right? Is that absolute value, right? A function. So how do we graph? We learned this before. So you use your t-table. So y, f of x is your y, right? Which is what? Absolute value of x. So if we put a 0, 1, 2, negative 1, maybe I do negative here, positive here, doesn't matter. So you take absolute value, so that would be this. Okay, when you graph it, because absolute value always positive, so your shape will be like this. It's a V shape. Okay, next thing we are going to see some example on the piecewise, something called piecewise linear function. Okay, then you can see its application. So let's do something about it to take a look. So if my y is f of x, so we say it's this way. Okay, that's on your page 11. So if x, so those are small number, we can just do it by hand. At the same time, if you do it on the computer, you have to do it separately. Okay, so we just use t-table, right, to graph it. So for the first one, x, y equals what? F of x is this one, 5 minus 2x. So it's negative 2x plus 5. So leading coefficient is negative 2. Your slope is a negative number, means what? Your line goes down. So, but we say x is what? Bigger than or equal than 2. So we do 2, 3, 4, 2 and up, right? So when we plug in, we have this value. So when you graph it, so what do you have? 1, 2, 2 is what? 1, 2 is 1, right? Then 3 is what? Negative 1, 2, 1, 3, negative 1, and 4, negative 3. 4, negative 3. So x is bigger than 2, bigger than or equal than 2. So you graph from there all the way down like this, right? Then let's see another piece. It says if x is smaller than 2, not equal to 2, smaller, then we do the t-table. Xy equals what? X plus 3. So it's what? 2. It's less than, so it's 1, 0. Okay, up to 2, but not 2. So we plug in the value, right? The slope y equals mx plus b, slope is 1. So this one is what? Going up, right? So if 2, that would be what? 1, 2, 3, 4, 5. So it's here. We use this hollow circle because it's up to 2, but not include, right? 1 is 4, right? 0 is 3. So your line is what? Going this way. The slope is still from left to right. It's going up to this point. So it's a positive slope. That's how we will graph a piecewise linear function. So we learned the basic one, what the rational functions are. They are fractions. You need to use calculators or use website to do it. But absolute value functions, you can do it by hand, and piecewise linear functions, if it's a linear, so you should be able to do it by hand. And we will see how we are going to apply the business with the piecewise linear function. How do we use it? What do they mean? Let's look at page 11b. How we are going to use piecewise linear function to show an idea. Okay, let's take a look. Graph an income tax function. So federal income tax are progressive, meaning that they take a higher percentage of income, high income. Okay, they charge you more tax if you make a lot of money. So that's the idea. So for example, the 2013 federal income tax for a single taxpayer whose taxable income was not more than $87,850. If they are not making more than this way, $87,850, okay, was determined by 3-part rule. 10% of income up to $89.25. So here is your $89.25. So your X is your dollars, the income. And Y is what? That's your tax, right? So tax, Y is a function of X. Tax is a function of what? Your income dollars. Is that right? So 10% up to, if you make up to $89.25. Then after that, you pay 15% any amount over that much up to what? 36,250. So in between here, you pay 15%, right? Above that. Below that, you pay 10%. Here you pay. Okay, in between here, you pay what? Additional, besides you make above that portion, you pay what? 25%. So if we look at the graph, that's how we are going to graph it piecewise. A piece at a time, okay? From $0 to $89.25. This equation is what? Y equals 0.10x. So our slope-intercept form, right? So 0.1 is m. M is what? 0.1. That means that's your slope. So it will look like this way. So 10%. So $0, you pay what? 0%. $0, 10%, pay $0. 8925, you times what? So 8925, you times 0.1, so you pay what? $892.50. So that means when you make this much, you pay tax 892.5. That's your Y value. So 10% rate, you will look like this. So your shape for the linear will be that way, right? Then beyond that, your function will be what? This one, right? So your Y will be 892.5 plus what? 0.5x minus 0.55 times 8925, right? So your x is what? Slope become y equals mx plus b, slope. So this one, this slope is what? 0.10, right? So after this, it gets higher up to here. So you will, that would be, slope would become what? Your slope is, right? So at this point, you plug in this value, then you should get the y value is what? This is amount, this point would be 4991. You plug in here, 25. So that's how much you will pay your tax. And after this, what's the equation? Y equals the last one here, right? So your slope is what? 0.25x plus something. So all the way to here. So that would be this. So it's right 5. Okay. So your slope it will be much higher like this. So your slope is 0.25. So you plug in the value for 80. If you make 87,850, you plug in to here, right? So your dollar amount would be what? 17891.25. So you can see gradually you'll pay more. So the rate of change, how's the slope at the same time is the rate of change. So how much money you make, how much more you have to pay. So y equals mx plus b, that's how we use the linear function to describe a federal tax with the certain number. Exactly, we are using the what? Piecewise linear function to do that. So that's for your section 1.6. And we are talking about polynomial functions and rational functions. Then also polynomial function, linear functions, including piecewise linear function. That's how we use to do the federal income tax. That will be your section 1.6.